Hello friends, now today again we will explain the relation. Okay, this is very important for the DMS course. Okay, for the DMS course this is very important for the GATE and NPTEL, and we will try to cover all the questions that has come asked also in the previous exam. Okay, so what is the definition of relation? So what we have written, let A and B be two set. Okay, a binary relation R from A to B defined as R is the subset of A cross B. Okay, so this is the relationship between two sets, that is the so now I will come this. Okay, now see here, so how to understand what is relation. Okay, now here in the first set I have taken two element. In my A there are only two element. Okay, in my A there are two element. So we are trying to teach you A cross A. Number first, we are trying to teach you A cross A, means relationship between A and A. Okay, so your A, our A is this. Okay, my A is this. So now how many ways we can start the relationship between A and A? Number first, from 1 to 1. Okay, we have written here. From 1 to 2 we have written here. From 2 to 1 we have written here. From 2 to 2 we have written here. So total are 4. Okay, so if I will write A cross A, total are 4. Okay, this is the first important, you have to note this important topic. Okay, so what is relation? Means you are creating the relationship between 2 points. Okay, now the second one, so there are total number of, now you can see there are total number of 4, you have 4 cases are, there are total number of 4 cases. Case number 1, case number 2, case number 3, case number 4. Okay, you have total 4 cases. So out of 4 cases, number first case, out of 4, suppose you want to select 0, 4C0. What is 4CR? NCR. NCR is equal to n factorial upon r factorial into n minus r factorial. So 4C0, 4C0 means out of 4 you will select 0. Okay, so we are representing that is 5, means null, nothing. Actually this is 0, means 0 0 0 0. Later we will explain what is matrix. Okay, now out of 4, at first total 0. Now out of 4 I want to select 1. Okay, so there are total number of 4 elements in my R. A cross A is equal to what I have written, 1 comma 1, 1 comma 2, 2 comma 1 and 2 comma 2. There are total number of 4 cases. Out of 4 cases, the first one, out of 4 I am selecting 1. So there are total number of 4 ways. First one is either you will select only 1 1. Second one is you will select 2 2. Third one is you will select 1 2. And fourth one is you will select 2 1. So total number of 4 cases are there. Okay, 4C1 is equal to 4. You can also solve. Next, so now second, maybe the user want to select, out of 4 the user want to select 2. So how many ways? So there are total number of A into A is equal to, there are total number of 2 cases, total number of 4 cases, sorry, there are total number of 4 cases. Okay, so the user has taken at first 2, out of 4 any 2, then any other 2, any other 2, any other 2, any other 2, any other 2. So total number of you will solve, then you will get 6. So there are total number of 6 cases if you will select 2 from A cross A. Okay, in A cross A there are total number of 4. Out of 4 if you will select 2, so such cases are total 6. Now next, suppose the user want to select 3 element. Third, user want to select 3 element. So after select out of 4, he want to select 3 element. So there are 4 cases, 1, 2, 3, 4. Okay, you can also check. So if you will select, then you will get 4 answer. Okay. Now next, suppose the user want to select out of 4 1. Okay, means out of 4 he want to select all. Okay, so that is 1 actually. So you can see this is my final. Okay, means this is actually A cross A. Out of 4, if you want to select 4, that is A cross A. So now the question is coming in your exam. The first question: if in A there are 2 element, 1 and 2. If there are 2 element, so total is equal to 16 relation. Okay, if there are total number of n element, then how many relations are there? This is 2 की power n square. This is very important, comes in GATE and NPTEL exam. Now, okay, you understand what is this? Now I will explain you something actually what we want to teach you. The first one, once we created total number of 16 relation. Okay, in this 16 relation, how many are reflexive, how many are symmetric, how many are antisymmetric, and how many are transitive, and which one is equivalence relation. Okay, this is the question we want to teach you. This question we want to teach you. Okay, so the first one is reflexive relation. What is reflexive relation? A binary relation on a set where every element is related to itself. Means if, what is this? If in A there are total number of 2 element, so what is the meaning of this? So 1 1 must be there, 2 2 must be there. Okay, so now you can see 1 1 is here, 2 2 is here, 1 1 is here, 2 2 is here, 1 1 is here, 2 2 is here, 1 1 is here, 2 2 is here. So this is reflexive, this is reflexive, this is reflexive, and this is reflexive. So in GATE exam, so there are total number of 4. In GATE exam, what they ask, if in a set A total number of n element are there, 1 2 3 4 up to so on n element, so how many reflexive relation? The formula is this. So for the GATE exam, this is very important. You will use 2 की power n into n minus 1. Okay, total number of reflexive relation. Okay, so there are total number of 16 relation. Out of 16, 4 are reflexive. So this in the exam they will give you this is reflexive or not. Okay, we will ask. Okay, then you will say this is reflexive. Okay, now next topic, symmetric relation. So what is symmetric? Symmetric means that is mirror image, just like 1 comma 1. You can see this is the mirror image. Suppose I am writing 1 comma 2, 1 pair, and its symmetric is equal to 2 comma 1. You can see. So what is the meaning of symmetric relation? If this, then this must be there. Okay, if A comma B in my R, it implies that B comma A must be there. This is the meaning of symmetric relation. Okay, I think that you understand. So so now if I told if this is available, then this must be there. Okay, so if it is not available, no meaning. So R1 is symmetric relation, R2 is symmetric relation, R7 is symmetric relation. You can see this is symmetric relation. R8 is symmetric relation. 1 2 is here, then 2 1 is here. Then you can see 1 2 is here, then 2 1 is here. Then 1 2 is here, 2 1 is here. Okay, then 1 2 is here, 2 1 is here. So every A is symmetric also. So R11, R14, R15. So out of total 16, there are total number of 8 are the symmetric. There are total number out of 16. Out of 16, if in my A there are only 2 element, then total number of reflexive relation are 16, and out of 16, 8 are the this symmetric. So this null is also symmetric. Okay, so if there are total number of n element, then the formula is this. Okay, 2 की power n into n plus 1 upon 2. Okay, this is the formula. If there are total number of n element in a set, then total number of symmetric relation is equal to 2 की power n into n plus 1 upon 2. This is the formula. Now next, antisymmetric. This is also very important. So antisymmetric means if AB is there and BA is there, then 100% A is equal to B. What is the meaning of this? What is the meaning of this? I will explain. I will explain you in a different form. Now see here, what is the meaning of this? Suppose you have 1, 2. Suppose you have 1, 2. Okay, suppose you have 1, 2. Okay, you know that if there is a 1, 2 and if 2, 1 is available, this is a mirror image, then it implies that this is symmetric. This is symmetric. Okay, so what he is saying? If 1, 2 is there, antisymmetric. What is the meaning of antisymmetric? If 1, 2 is there, then its mirror image should not be there. Okay, if mirror image is there, it implies that, so what is this? 1, 1 should be there. Means A is equal to B. Means 2 and 1 both must be same. So if 2 and 1 both must be same, what is the meaning of this? Both must be same. Okay, that is impossible. What is the meaning of this? So 1, 1 must be there. 2, 2 must be there. The meaning is this: either 1, 1 or 2, 2. What is it? Means mirror image. If 1, 2 is there, then if 1 minute, I will use. What is the meaning of this? If 1, 2 is there, then mirror image should not be there. Okay, should not be there. If 1 A, B and B, A is there, it implies that A and B both are same. The meaning of this. Okay, so 1, 1 should be there, and I think that you understand. If you are not able to understand this example, it will clear your topic. Okay, this topic. So antisymmetric, what I told you, antisymmetric. So 1 is antisymmetric. You can see 2 R2 is antisymmetric, 2 is antisymmetric, 1 is antisymmetric, and 2 is. Why? Because 1 is there but 2 is not here. Okay, this 2 is not here. 2 is here but 1 is not here. So this is antisymmetric. So R5 is antisymmetric. Similarly, R6, R9, and R10, R12, R13, and 5 is also antisymmetric. So total number of antisymmetric are 12, and if there are total number of n element, then the formula is this. This is the NPTEL and GATE exam. Many times they ask 3 की power n into n minus 1 upon 2 into 2 की power n. What is this? Sorry. I will write here. If you are not able to understand, I will write here. Okay. What is this? This is 3 की power n into n minus 1 upon 2 into 2 की power n. I think that this is correct. Okay, I will check. 3 की power n into n minus 1 upon 2. Okay, 3 की power. So 3 की power correct है ना? 3 की power n into n minus 1 upon 2 into 2 की power n. So this is the formula. Now next, after antisymmetric, transitive relation. So what is the transitive relation? Transitive relation means, I will explain you transitive relation. Okay, I will explain you transitive relation here. So now again, transitive relation. What is the meaning of transitive relation? So if A, B, if A, B belong to R and B, C belong to R, it implies that A, C must be belong to R. What is the meaning of this? If 1, 2 belong to R, है ना, and 2, 3 belong to R, it implies that 1, 3 must be belong to R. Okay, if it is available in R, this is also available in R, then this must be in R. What is the meaning of this? Okay, you understand. If it is not available, anyone is not available, then okay, no problem. Okay, I will show. Okay, now see here. So transitive relation. So first one, this is 1 is transitive relation because nothing is here. 2 is transitive relation, 1 is transitive relation, 2 is transitive relation. Okay, so now you can see this one is also transitive relation, this one is also transitive relation, this one is also transitive relation, this one is also transitive relation. So we solved many question. Okay, one by one you can start argument why this is transitive relation. Okay, so now you can see here 1 and 2 is belonging to R, 2 and 2 belonging to R, so 1 2 is also belonging to R. This is very important. The last one is very important. So you can see 1 2 belong to R, 2 1 belong to R, so 1 1 also belong to R. Okay, 5 is also transitive relation. So total number of transitive relation are 13. Now the question is, if there are n elements, then how many transitive relation? Okay, so there is no such formula, so I have written something. Okay, if there is no element, then total number of transitive relation 1. If there is one element, total number of transitive relation 2. If there are 2 elements in my A, then total transitive relation 13. If there are total number of 3 elements in my A, then total transitive relation 171. And for 4 3994, and this is my series 1, 2, 13, 171, 3994, 154303, 19415189, up to so on. Okay, so these are all the transitive relation. Now the second question is very important. What is the why we are teaching you this relation? This relation is very important in DBMS, database management system. Okay, in database management system we will also teach you relationship in types of relationship. Okay, so there are total number of 3 types. One is one-to-one mapping, second is one-to-many mapping, third one is many-to-many mapping. Okay, you can see also, if you know little bit about the DBMS, or if you go in our, so you can see that this is the one-to-one relationship between 2 table. This is 1 table and this is 2 table. So 2 table you can also start the relationship between. Okay, by the help of primary key you can fetch the data, by the help of foreign key you can also connect. Okay, second one is one-to-many. Okay, you can see also we are creating the relationship between 2 tables. Okay, 2 tables. So such things already we are using in our computer science. So this is very important to understand the many-to-many mapping. Okay, so by the help of this we can find the whatever we want. Okay, so now next topic, I will show you this is also very important. Why this is very important? Graph and metric representation of the relation. So first one already we explained. Go to the previous one, or maybe all the people they are writing the notes. Okay, so which one is reflexive and which one is symmetric, which one is antisymmetric, and which one is transitive. So first one, reflexive, I told R7, R12, R13 and R15 are the reflexive. So now you can see 1 1 I am writing this matrix. What is this? I will show you. Now see here, matrix representation I will show. So if you are not able to understand, now you will understand. Okay, this is very important. Suppose you have 1, 1, okay, and you have 1, 2. So how to write matrix? At first you will write 1, 2 here, 1, 2 here. Then you will start the matrix here. So 1, 2. In here 1, 1. 1, 1 is here. So I will write 1 here. Then 1, 2. This is 1, 2, 1, 2. So there is no 2, 1. I will write 0. There is no 2, 2. I will write 0. So in my set there are only 2 pair. One pair is 1, 1 available. One pair is 1, 2 available. So I am writing 1, 1, 0, 0. Okay. So by the help of this we can also show the matrix representation. Okay. This is very important. So similarly, you can see we have also created the matrix relationship for R12 and R13 and R15. So this is my matrix representation of for reflexive property. Okay, I think that you understand. Now, okay, now next, so symmetric. Next, I explain the symmetric relation. So in the symmetric relation, if you are noting, you have already written in your notes. R1 is the symmetric relation, and R2 is the symmetric relation. R7, R8, R11, R14, R15, and R0. This is the symmetric relation. So symmetric relation, this is my matrix representation for R1. This is my matrix representation for R2. This is for R7. This is for R8. This is for R11. This is for R14. This is for R15, and this is for null. Okay. So what is null? Null matrix means out of 4 I am not choosing anyone. Okay. So this is the symmetric relation. Okay. Now next one, antisymmetric relation. Antisymmetric relation, again, how many we have selected? R1, R2, R3, R4, R5, R6, R7, R9, R10, R12, R13, and R0. So out of total number of, if in my A there are total number of only 2 element, so total relations are 16. Out of 16 total number, these are my antisymmetric relation, and this is the representation of matrix. Okay, this is my antisymmetric and its matrix representation. Okay, similarly everything we have explained. This is my antisymmetric and this is the matrix representation. Okay, so this is also very important. Now next, same for transitive property. Okay, already we explained. These are all my transitive property out of 16. What I told, in my A there are only 2 element, 1 and 2. So total number of relations are 16. Out of 16, these are my transitive property. This transitive relation. Okay, so and this is my matrix representation. Already we explained. These are my matrix representation. Okay, so by the help of matrix also we can find this is the transitive property. Okay, this is holding transitive property. Now this is very, very important. Okay, without checking, you can see this, the first one, R0 is equal to 5 is the satisfying all of the property of relations, means only except reflexive property. So R0 is equal to 5 is symmetric, is antisymmetric, is transitive. This is everything. Okay, so this is the not reflexive property, and A star A is the equivalence relation. So now you can see this is my equivalence relation, and this is my this is not the reflexive property, but it is symmetric, it is antisymmetric, it is transitive property. Okay, so by the help of matrix also we can say the conclusion. Okay, you can see also this is very, very, very important for your GATE exam or another exam, and for your JNTU also this is very important. So this is my n into n matrix representation and transitive property. You can say this is one is the transitive property, this is also transitive property, this is also transitive property. Symmetric, this is the symmetric matrix, this is symmetric matrix, this is symmetric matrix. You can see also this is symmetric matrix, this is symmetric matrix, this is symmetric matrix. Okay, so by the help of matrix also we can say such will hold the property of relation. Okay, you can see symmetric means mirror image at diagonal. Now the another one is very important, total number of possible equivalence relation. What I told equivalence relation, I will explain something. I will explain something here. So again, this Microsoft, I don't like Microsoft. Why? Because of this is a problem in Microsoft. Okay, it is taking so much time. Now see here, I will show what I want to explain. I want to explain equivalence relation. So equivalence relation means if it will satisfy number first reflexive property, number second symmetric property, number third transitive property. Okay, if something will satisfy, any relation will satisfy reflexive property, symmetric property and transitive property, then you will say this is the equivalence relation. Just one example, suppose A is equal to 1, 1 and 2, 2. Okay, only A is equal to, sorry, R is equal to 1, 1, 2, 2, where A is equal to 1, 2. Okay, means in A there are only two elements. Sorry, in A, again I will write. Suppose in A there are only two elements, 1, 2. Okay, and suppose my one R, there are many R. I told total number of 16 R. 16 relation. Out of 16, suppose I am taking only 1, 1, 2, 2. Okay, so I am asking, this is reflexive? Yes, because both are here, every A is here. Okay, this is reflexive, this is symmetric, this is transitive also. So this R is the equivalence relation. So we have to find, if in a set there are total number of 2 elements, then how many are there? Are total number 16 are. Out of 16, how many are equivalence relation? If in a again I will write, suppose in A there are 3 element, 1, 2, 3. Okay, 3 element. Then my question is, how many equivalence relation are there? What I told, 2 की power n square, this is formula. So 2 की power 3 का square, 3 square means 3 3 is 9, 2 की power 9, 2 की power 9 is equal to 251. Okay, you can check also. So out of 251, how many are transitive relation? Okay, how many are transitive relation? How many symmetric? How many antisymmetric? How many transitive? And how many equivalence relation? Okay, we are asking equivalence relation. So now I will again go to my point. So what I told, equivalence relation. Okay, so there is no such formula. One formula. This is the Bellman. Okay, one formula, Bellman. I will show. The Bellman, he discovered this formula, Bellman. So he has given one formula. By the help of this formula, you can find the exact answer. So here I will not waste your time. Okay, so you should remember, if what is this, I will explain. If there are total number of only one element, then total number of equivalence relation are this. This is the max value, is the equivalence relation. If there are 3 elements, then total number of equivalence relation are 5. If there are 4 elements, then equivalence relation are 15. If there are 4 elements in set A, then total number of equivalence relation are 52. Okay, so my question was, if there are, okay, so now see here, in this question, what I ask, I will show. 1 minute, है ना? So 1, 2, 3, 4. There are total number of 4 elements. So if there are total number of 4 elements, total number of equivalence relation are 15. This question multiple times NPTEL also they asked. Okay, NPTEL also they asked this question. Slide show. Okay, so what I told, so you can see also, this is a very problem in this. Okay, so if there are total 4 elements, then total 15. So 4, then 15, 3, then 5, 2, then only 2 equivalence relation, 1, then 1 equivalence relation. What is the meaning of this? If A has 3 elements, then total number of equivalence relation are 5. So my question was, if A has only 2 elements, then total number of equivalence relation are 2. This is my answer. Okay, now I think that you understand. Now next one is graph representation. Already we explained the graph representation. So you can see this is the 1 is going to 2, 1 is going to 2, so 1 is going to 2. Okay, there are 3 elements, 1 going to 2. Okay, 1 going to 2, you can see 1 going to 2, so I have written here 1. Okay, then 1 going to 0, 1 going to 0, 1 going to 0, so I have written 0 here. Okay, 1, sorry. Then 2 is going to 0, 2 is going to 0, 2 is going to 0. Okay, then I have written 1 here, and where I am not writing means there is no such direction. So this is my representation. Okay, so you can see by the help of this R, this R, by the help of this R, okay, I can represent the matrix as well I can represent also the graph. So this is very important. Okay, directed graph. So I think that you understand the adjacency matrix. This is very important. So my request to everyone that we covered all the questions already asked in GATE exam last time and NPTEL. So my request to everyone that please share to your other friends. Okay, so it will be very helpful for them. Okay, thank you so much. Students, today again I will solve some JNTU problem. Okay, so these are very important, some JNTU for the DMS. So what we explain in our lecture, the reflexive property, symmetric property, transitive property, asymmetric property, antisymmetric property, and irreflexive property. So this irreflexive property, okay, some questions you will understand. Okay, now I am solving one question. Okay, your concept will clear. So already we have solved total number of 16 question. Okay, now again I will solve one question. So this time in my set total number of 3 elements are here. So total number of elements are 3, means 2 की power n square, means 3 square, 3 3 is 9, 2 की power 9, 2 की power 9 is equal to total number of 512 relations are there. Out of 512 relation, I am just choosing only someone and I am asking these are reflexive or not. First question, this is my first question. Okay, in my first question what we are asking, see, so first question what we are asking, R1 is equal to 1 1 2 2 3 3. Okay, so R2 is equal to 1 1 1 2 1 3, R3 is equal to 5, R4 is equal to A cross A, R5 is equal to 2 comma 2, 3 comma 3, 1 comma 2, and R6 is equal to 2 3 1 2. Okay, so which one is reflexive and which one is symmetric and transitive? So this is my overall table. Okay, so same we will ask. So why this is not reflexive? Okay, this is not reflexive, R2 is not reflexive. Why? Because of in my set total number of element are already we explained 1 comma 2 comma 3. So 1 1 is in R1, R2 1 1 is here. What about 2 2 and 3 3? So 2 2 and 3 3 are not here, so R2 is not reflexive. R6 is not symmetric. R6 is not symmetric. Why? Because of 1 2 is here and 2 1 is not here. Okay, so this is not reflexive, not symmetric. Is not transitive. This R6 is not transitive. Why? Because why this is not transitive? See here, if I will write 1 comma 2, okay, I am writing at first, then I am writing 2 comma 3. Okay, now see, 1 comma 2 is here, 2 comma 3 is here, 1 comma 3 is not here. What I told, A comma B. If A comma B in my R and B comma C in my R, then A comma C must be in my R. This is the transitive property. Okay, so this is not transitive property. Okay, so already we discussed about the reflexive, symmetric and transitive. I think that you understand. Now similarly another example. We have solved many example. In this example, we are asking to you, what we are asking? We are asking if A has total number of 4 elements, 1, 2, 3, 4. Suppose R1 is equal to this one, 1, 1, 2, 2, 3, 3, 2, 1, 4, 3, 4, 1, 3, 2. R2 is equal to A cross A, R3 is equal to 5, R4 is equal to this one, R5 is equal to this one. Then I am asking which one is reflexive, symmetric, antisymmetric, asymmetric, irreflexive and transitive. Okay, so one by one you have to solve everything. Now you can see, if you have any doubt you can ask us why R1 is reflexive. R1 is not reflexive. R1 is not reflexive because 1, 1, 2, 2 is here, 3, 3 is here, but 4, 4 is not here. 4, 4 is not in my R1, so this is not reflexive. Okay, this is not symmetric. Why this is not symmetric? R1, this R1 is not symmetric because 2, 1 is not symmetric because 2, 1 is here, 2, 1 is here, but 1, 2 is not here. Okay, so this is not symmetric. So this is very important table to understand the all property: reflexive, symmetric, asymmetric, antisymmetric, irreflexive and transitive. Okay, so this is very important. Now you have to note one thing. This is R3. R3 is equal to 5. R3 is equal to 5. You can see R3 is everything. R3 is everything except reflexive. What is the meaning of this? R3 is everything except reflexive. Number first means 5 is everything except reflexive. Second, R5. What is R5? R5. There is R2. What is R2? R2. R2 is equal to A cross A. R2 is equal to A cross A. So R2 is A cross A. This is not asymmetric. This is not antisymmetric. This is not irreflexive. This is transitive. So every R cross R, what I told, every R cross R means A cross A is equivalence relation because it is transitive, it is symmetric, it is reflexive. What I told, conclusion, every R cross R is equivalence relation and every phi is will hold all property except reflexive. These two are very important for the GATE exam. Okay, thank you so much. You must also share these questions to your friends. This is the JNTU problem. Okay, so this is also GATE problem they asked. Okay, thank you so much. Please share to your friends.